Good afternoon, students. I am Priyanka Sharma, Assistant Professor, EC Department, AKGEC, Ghaziabad. I am going to discuss the topic in the subject Fundamentals of Electronics Engineering, that is BC 201. In this, we are going to talk about the topic that is related to Unit 1, that is Fundamentals of Communication Engineering. In this, we are going to talk about the topic that is diode clippers. So, the contents of the discussion are diode clippers, series and parallel clippers. So, we are going to discuss about the very important application of the diode, that is clipper. So, this is the important application of the diode that can be used in various electronic circuitries. Application of diode. This is called as clipper. So, diode can be used as a circuit which can use to remove some portion of the signal. We have a signal like this. We have an AC signal. We can remove the signal either from the positive end or from the negative end. And this is known as clipping. This process of removing some portion of the signal, is called as clipper. So, in this, we can set any reference point at which we want to remove the signal. So, this can be utilized in various important applications in communication field, in the radio applications and different applications of the electronics equipment. So, we will going to discuss about the basics of clipper. First of all, starting with the classification, we have the clipper circuit. This is the clipper. Clipper is first divided into two types of clipper, that is series and parallel configurations. And among these two configurations, we again have divided the different type of clippers, that is biased clipper. We are going to use biased positive clipper. We can say positive biased clipper. We can say negative biased clipper, and we can also discuss about combinational clippers. So, these are the classification we are going to discuss about the clippers. So, now next we are going to first talk about the series clipper. Series clipper without biasing. So, series clipper without biasing, if we talk about, in this we will going to use the arrangement of the circuit. We will going to use the diode in this way in series configuration, and the resistor is taken as load, and we will give the input at this end of the signal. I am going to give the signal here, that is I am going to give the AC input signal Vin having the peak amplitude Vm, and this diode I had taken as ideal diode. If I take this diode as ideal diode, and I will take the output across the V out, that is the load resistance RL. So, this analysis we can do. So, for the AC input signal, we call this as AC analysis. So, by AC analysis we can find the output here. So, first we are going to divide the analysis in two parts, positive cycle and negative cycle. So, for positive cycle we call this as positive analysis. So, for positive cycle of the signal, first we are going to talk about here whether the diode will be forward bias or reverse bias. So, for the positive cycle, the very first end, this end will become positive and the lower end will become negative. For this connection, diode will become forward bias. Diode will become forward bias and current starts flowing. Current flows. So, when the current flows, and in this I am taking the diode as ideal diode, so the current starts flowing and it behaves like a short path. So, the equivalent circuit will be like this. This is the equivalent circuit. I have this input signal. This is the input signal Vin. This is the Vin signal, and it is behaving as a short path. So, what is the output we are getting here? The output will be, output is equals to this. If we apply the KVL here, So we have the input signal V in, which is the positive cycle. So output is similar to V in. So if we draw the waveform here for the positive, for this clipper circuit, I am drawing this waveform here. This is the input signal I am taking. This is your V in input with peak amplitude Vm. So for the positive cycle, the output is same as V in. So output is drawn same as V in. That means peak voltage is also equals to Vm. So for the positive cycle, we get the same output. Now if we talk about the negative cycle, if I am going to take the negative cycle. For the negative cycle, we have, for the negative cycle, diode will become reverse bias now. So for the negative cycle, if I take this end will become negative and the lower end will become positive, the diode is now going to be reverse bias. So in this case, what happens? The circuit or diode will behave as an open circuit. So we will get no current. So for this condition, if the no current is there, I is equals to 0. In that case, the output voltage obtained here is also equals to 0. So for this condition, if I am going back to that slide, the output voltage for negative cycle I am getting here is 0. So in this case, we can say the negative cycle is clipped here. This is clipped. So this is said to be the negative diode clipper. This is said to be negative diode clipper. Now, so this is the simple circuit we had studied about the series clipper. Now if we're going to add the biasing in this, so if we're going to add the bias clipper, so we can have, in this we can observe here complete either positive cycle will be clipped off or a complete negative cycle can be clipped off. Similarly, if we want to draw the positive diode clipper, we just have to reverse the connection of diode. So by just reversing the connection of diode, we get the positive diode clipper. So we can talk about next about the positive diode clipper. The positive diode clipper is same as negative clipper. Positive diode clipper, in this only the connection is reversed. Diode will be connected in the reverse manner as it is connected in the previous circuit. So this is the positive clipper. So in this we will get the output where the positive input is clipped and we get the negative cycle only. So this is called as, this is said to be positive diode clipper. Now next we will going to talk about the biased series biased clipper. So in this case, we are going to add up a DC battery so that signal can be clipped off at any level of the signal, as we had talked earlier. So if we want to clip the signal at any point of the circuit, we can use the different circuit. In this, I had connected one battery here. Suppose I had connected this positive battery. Let's say this is 5 volt and a diode is connected like same as in the previous case. We have a resistor R and I had given the input signal AC input. Let's say this is at 10 volt. I had taken the peak voltage as 10 volt. This is our input signal. So this is the circuit I had taken and I will again take the output across the resistor, that is V out. Now for this analysis again we will start with the positive cycle as well as negative cycle. But in this case we have to just keep into mind we had inserted one battery here in the series. So this we have to take into account. So if we have to take into account, we have to take the diode connection in this way and we have to calculate the voltage just before the diode so that we can check whether the diode will be forward bias or reverse bias. So first we are going to calculate the V1. So V1 will be calculated in this way by just applying the KVL minus to plus. If we take this as a positive cycle or simply I am taking the input voltage V in. So this is calculated as V in and this is plus to minus. I am getting this value as, or we can say this is this I had taken as minus 5 volt. So this is the voltage I am getting. So in this case, if I draw the cycle of the signal, this is the cycle of the signal, this is the input cycle, and this output I will draw. So for this input signal, we have the peak amplitude at 10 volt, and I can draw the DC voltage here or mark here in the positive cycle, because the positive is connected to the positive end of the source. So I can connect this at the positive end, and I can draw the projections over the output here. And we can observe here less than 5 volt. If Vi is less than 5 volt, we had certain other output, and if I take the output Vi greater than 5 volt, we have the another set of output. So this equation I had written here, we can observe here, and we can check the cases, different cases, by taking it for different values of Vi. So if I take, this is the V in, this is V in, I can take here. So if this V in value is lesser than 5, if this V in value is, let's say this is lesser than 5, this is the case 1 I am taking. So in this case, what happens? If this V in value is lesser than 5, V1 will be always negative. V1 is always negative. So if V1 is negative, diode will always remain, for lesser value, diode is always reverse bias. That means it is behaving as open circuit. So in this case, what is the equivalent circuit we have? We will get the circuit like this. This is the input signal, and this is the battery, and this diode will be act as open circuit. So in this case, I will get the output as 0. So I am getting the output as 0 because the current is 0. So if the current is 0, output will also be equals to 0. So for lesser than Vi, lesser than 5 volt, we will get the 0 output. So it can be marked here. So it can be marked here. And now if we take the another case, that is case 2, that is the case 2. In this case, if I take Vn greater than 5, if I take the Vn greater than 5, in this situation, V1 will be positive, and for the positive value, diode will be forward bias and behaving as short circuit, behaving as short path. So for this, what will be the equivalent circuit? So in this case, I will got the equivalent circuit as diode is behaving as short path, and we will get the output. We will get the output like this. And in this case, how the output will be calculated? This output will be calculated by applying the KVL. So what is the output here? I am getting output will be equals to, by just applying the KVL, we have V out equals to V in minus 5. So output is coming out here is V in minus 5. So by graphical analysis, we can plot the output after the 5 volt. So if we plot V in equals to 5, let's say if V in equals to 5, then what will be the output? Output will be equals to 0. So it is marked here, output will be 0. Now if we take the V in as peak voltage, that is if V in equals to plus 10 volt, then for this V out will be equals to 5. That means the peak voltage is coming up to 5 volt. So this is I am getting as 5 volt. Now again coming back to V in equals to 5, again V out is coming back to the 0. After this, if you check it from here, if I take the V in is again going to be lesser than 5, and if V in is lesser than 5, in that case again the case 1 will going to occur. In this case again the diode will be reverse bias and become open circuit, and in this case output will be equals to 0. So the graph obtained here is like this. So we can say the some negative portion along with positive portion can be clipped off. So this can be said to be the biased negative clipper. So similar to this is the series bias clipper. So similar to this is one configuration. We can draw 3 more configurations also by changing the direction of diode or changing the direction of battery. So we have different combinations, and these circuits can be used for different clipping of the signals at any level by changing the biased battery. So we can see the 3 more configurations also. So we have another configuration. This is another configuration. In this, battery is keeping as it is, positive this side, negative this side. Diode direction will be changed. So this is another configuration. In this, we have this input here, and in this case, the output obtained will be, this is also, let's say, 5 volt, and in this case we have, this is the peak voltage, that is 10 volt, and this is 5 volt. In this case also, if I am considering this V1 voltage, this is V1 voltage, V1 is taken as Vin minus 5. Only the case 1 here, if I take Vin lesser than 5, in this case V1 will be negative, and in this case diode will be forward bias first, and the Vout obtained here is equals to Vin minus 5. So if we take, if we plot this graph in the similar way as we plotted earlier, this is the input I had taken Vin, and this is the 5 volt DC supply I had marked, and draw the projections here for the output. We have this output. So if I plot this, first I had taken the Vin equals to 0. So what is the value of Vout? Vout is coming out to be minus 5. That means in this case, reference is going to shift it to minus 5 volt. And after this, if I take the peak voltage as, it is up to, I am taking this Vin as 5, then Vout is coming out to be 0. That means it will go up to 0 volt. Up to this, it will be giving the output. After this, if I am taking the case 2, in this case, if I take the Vin greater than 5, in this case V1 will be positive. For this, diode will be reverse bias. So in this situation, it will become open circuit, and again the Vout will be equals to coming out to be 0. So in this, output will be 0. Again, this is the same case, that is Vin less than 5, and this is Vin greater than 5. Again, if Vin greater than less than 5 occurs, then again same situation will going to happen here. In this case also, I have the output obtained, and for negative cycle also, I will get the same output. But only the difference is, for the negative cycle, for the negative peak, what will be the output here? If I consider Vin as minus 10, so minus 10 minus 5, the negative peak is coming out to be minus 15 volt. So this is minus 15 volt coming here. So only the small portion of positive cycle will be clipped. So this is called as positive biased clipper. So in this way, these circuits can be analyzed. So this is all about the series configuration. Now next, if we are going to talk about the parallel configuration of clipper. So first of all, talk about the very basic thing of the parallel diode clipper. Parallel diode clipper configuration. In this parallel configuration, the output is taken across the diode. So again, it can be divided into 2 parts. It can be positive clipper, or it can be negative clipper. Positive clipper, and it can be negative clipper also. So if we talk about the basic circuit, first of all, I am talking about the basic circuit. I have taken the resistance here, and this is the input signal I am giving here. This is the V input, any input signal having the peak amplitude Vm, this is Vm, and I had taken the diode here. So diode can be in this direction also and can be in the reverse direction also. So I will take the output across the diode, and this is the resistance coming here. So in parallel diode clipper, resistor will come into series and diode will be taken here, and output is taken across the diode. So if we are going to analyze this parallel diode clipper, first again we are going to start with the positive cycle. So for positive cycle, what will happen here? For positive cycle, this end will become positive and this end will become negative. For this end, this is positive. So this diode will be reverse bias here. So in this case, positive cycle, diode will be reverse bias and act as open circuit. So if we draw the equivalent circuit here, so what is the equivalent circuit I am getting here? This is the equivalent circuit. This is V in, this is resistance here, and the diode will be open circuit. So what will be the output here? We all know कि output across the open path will be same as source voltage. So again the V out will be equals to V in voltage. So if we draw the circuit, in this we can say for the positive cycle we will get the same output as the input. So if we draw it in the cycle form, in the next step, for the first we will going to see it for the negative cycle. Again for the negative cycle, if we redraw this circuit, this is the resistor and this is the diode I had taken. So for the negative cycle, how will you going to analyze? For negative cycle, this end will become negative, this is positive, and for this negative, diode will become forward bias here. So diode will become forward bias and acting as short path. So in this case, if we draw the equivalent circuit, we have this diode is short path. So what is the output here now? We all know that output voltage across the short path will always be considered as 0 volt. So if we draw the cycle here, this is the input V in and peak amplitude Vm. So output here plotted as, for the output for the positive cycle, we get the output same as input. So it can be drawn same as input and peak voltage Vm, and for the negative cycle we get the output 0. That means negative cycle is clipped here. So this is said to be again negative clipper. This is called as diode parallel negative clipper. So in this way you can form different type of clippers, either it is positive clipper or negative clipper, or either it is in series configuration or it is in parallel configuration. So similar to this, we'll again going to talk about the biased parallel clipper. So the biased, if we talk about the biased parallel clipper, in this again we'll going to insert one battery along with the diode. So for the biased parallel clipper, we have again the different configuration. First we'll discuss about the very basic configuration. We have the circuit, we have the input signal here, that is again I am taking the example as V in voltage. I am taking the peak voltage as 10 volt. This is the input voltage and this is the resistance I had taken. I had taken one diode here and a battery is connected along with this. So this is said to be in parallel configuration. I have to take the output across this. So this is the circuit of biased parallel clipper. Now if we are going to analyze this, we are going to analyze in the same manner as we had analyzed the series biased clipper. So in this case, if we first talk about the positive cycle, we need not to take the total voltage. I can just compare, this is the input voltage. For positive cycle, this end will become positive and this end will become negative. So we can consider here, this is called as, treated as plus V in potential. And if this called as 5 volt potential, we just compare these two voltages across the diode to check whether the diode will be forward bias or reverse bias. So for the positive cycle, we are going to analyze. Before that, we will going to draw the cycle and I am going to mark the DC level here. Again, we had draw the cycle for input cycle and mark the DC level in such a way we have the battery positive in the upward direction or it is connected to the positive terminal of the output. So it will be marked in the positive side of the cycle. If the battery terminal is opposite, suppose the negative terminal is connected to the positive of output, then it will be drawn in the negative side. We will see that example also. So for the positive cycle, first we're going to start with, I am checking the case 1. Case 1 here is, first we will take V in lesser than 5. So in this case also, I am taking V in lesser than 5, and above this I am taking V in greater than 5. So for V in lesser than 5, again we are going to draw the projections here for the lesser than 5 and at all reference levels. So if we take V lesser than 5, that means V is at lower potential and 5 is at higher potential. So lower potential is connected to negative terminal of diode and higher potential is connected to positive. That means diode will be forward bias. So in this case, diode will be forward bias and becomes short path. So for this, we can draw the equivalent circuit. So this is the equivalent circuit I am getting here. So diode is acting as a short path and we have a battery here. So for the positive cycle, we will get the output, or we can say we will get the constant output, which is equals to 5 volt. So we can draw the value as plus 5 volt for V lesser than 5. So we have a voltage we obtained, that is plus 5 volt. Now we can take the second case, case 2. If I take the case 2 here, in this I am taking V in greater than 5. For V in greater than 5, what happened? This we can treat as higher potential. For this we treat as higher potential, and this I am treating as lower potential. So higher potential is connected to negative side of the diode now. So in this case, the diode will become reverse bias and treated as open circuit. So how will you draw this circuit? This circuit can be drawn like this. Diode is acting as open path and remaining things can be drawn like this. So what is the output? Now the output is same as input, because we know at the open path, output will be same as the source voltage. So we will get the output same as V. So the remaining cycle can be drawn as it is. Remaining cycle, or we can say for positive, this can be drawn as it is. Now again, if we take the case 1, V lesser than 5, we again have a short path and we again have a output voltage 5 volt. So for throughout the negative cycle, we will get the output constant, which is remaining at 5 volt. So in this way, you can draw the biased parallel clipper circuit. So this is one configuration of biased parallel diode clipper. If let us see, we will take the another configuration of diode biased clipper. Let's say we had changed the battery terminals. Diode will be in the same configuration. I had changed the battery terminal. Above is negative and lower is positive. So for this, if I can draw the output, that is, we can plot here. So this is again input I am taking. Same example, I am taking the maximum voltage is 10 volt and this is the input voltage. Again, I am taking here the two cases, case 1. For case 1, I am taking V lesser than 1. Before that, I am going to mark the cycle and DC levels here. So this is the input signal. This is the V in. This is 10 volt marked here. Here, the battery polarity negative is connected to positive of output. So it is marked in the negative cycle. So this is minus 5 volt. And again, I am drawing the projections in this way. Now, in this case, I am going to take this value V in, which is lesser than minus 5. This is lesser than minus 5 and above is V in greater than minus 5. So again, we will take the two cases. Case 1, I am taking, first of all, case 1 I am taking, in this case I am taking V in lesser than minus 5. So for V in lesser than minus 5, this is plus V in. So this is plus V in and this is minus 5. So this is now I am taking V in lesser than minus 5. That means that this is at lower potential and this is at higher potential. This is at lower potential and this is at higher potential with respect to this. So, lesser than -5, this is at lower potential. This polarity can be changed because we are taking both the cycles negative. So, this lower potential is connected to lower side of the diode and higher potential is connected to positive of the diode. So, the diode will become forward bias now. So, in this case, diode will become forward bias and acting as the short path. Circuit will be redraw like this. It will be short path and output will be coming out to be, what will be the output? It will be coming out to be -5 volt. So, for this value, lower value, when Vin is lesser than -5, in this case, I am taking the voltage as -5 volt. Now, if we take case 2, that is Vin greater than -5. In this case, what happens? This is now at higher potential and this is now at lower potential. So, for this, higher is connected to negative end. So, in this case, diode will be reverse bias and becomes open circuit. So, what will be the circuit now? In this case, I am getting, this is the open circuit and the input will be coming at the output side. So, the output will be equals to Vin. So, the remaining cycle will be as it is. So, this will be drawn like this. And only some portion of the negative cycle will be clipped. So, in this way, the diode clipper, parallel clipper will be formed. So, this will be enough for this lecture. Remaining clamper circuit we can cover in the next lecture. So, thank you for the same. Thank you.